that change in value of the instrument responding to a change in the process. Okay? Does that answer the question? Does that help? Yeah? Any other questions?
มีคำถามไหมคะเรามีของขวัญเล็กๆน้อยๆจาก APEC นะคะถ้าเกิดท่านใดมีคำถาม
Test. Okay, Mr. Mika, I have some question about the new APEC instrument.
Sure.
Yeah, because I'm worried about the sample pump of the APEC instrument because the new one is a smaller one, right? Smaller is I worry about the capacity of the vacuum head of the sample pump. When we sampling on the stack that have a PG is minus around 200.
Yep.
Is available for sampling on that condition or not?
It is. It should be okay. So free flow, so no vacuum, no anything on the pump is 70 liters a minute.
Yep.
Okay, it's free flow. At 5 inches, which is what's the millimeter? I can't remember, but
because
whatever.
I'm checking the last model.
Yep.
At the minus 15, the old model can section in around 42 liters per minute.
42.
But, yeah. For new
So at 15, this can do about 22 liters per minute, okay?
Around two times.
So
lower.
less,
Yeah,
okay.
less
But we have most of the time, that's going to be more than enough, okay? Maybe 90% of facilities will not need that bigger. It's a huge pump, too big, oversized. But we have an option where we have a booster pump.
Yep.
So we actually have, let me see if I can get a picture here real quick. So we have a model, if you want to see. Let me show real quick here. So this one here, which is the same as the one we have in the back.
Yep.
This is our sample.
Yep.
And our pedo lines here, okay? We have a model that has 2 extra connections right here.
Okay.
We can add a second pump to this to increase our
suction, right?
Our suction when we need it. Because it's maybe only 10% of the time we need really, really high suction, okay? I mean, when you're sampling method 5 and you're getting to 10 inches, 12 inches, it's probably time to stop. The filter is full of dust or there's something in the system that's overloaded. So we do have, and the reason we did this, especially for some of our customers in South America, they're sampling at really high altitudes in the mountains, and this affects the pump suction. So they need to add the external pump. They work together. So you now got 2 pumps working together to increase it. It's great. It's small. It's maybe, so it's the same pump that's in that one.
Yeah, I see.
In a small.
Yes, small case.
With a handle, really easy to carry. Yeah, it's not the big one that you have for the manual.
Yeah, I understand.
So now when you need it, you can plug it straight in. So your umbilical would come, plug into the external pump, then the pump connects to the console. So it comes before the
Okay.
And now you can get as much suction.
Okay. I want that. I just worry about this model not show the option.
Yeah. So we have over 50 of those consoles in the UK, in England. We have one customer that has one site that they need the extra booster pump.
Yeah.
Everybody else in every site, this is perfectly fine.
Yeah. Okay. Thank you for your answer.
You can talk to these guys.
Yeah.
That's a possibility.
Yeah.
And you can use that pump for anything. If you want to draw a bag sample, gas bag, you could use that pump. So it's a good little extra to have.
Yeah. Thank you.
Any other questions? So we got one session left, which is going to be mercury. So again, we're going to discuss the reference methods, which you might know based on isokinetic sampling, and how they compare with the new reference method 30B. It's going to be completely different to anything you've ever seen. It's not isokinetic. There's no nozzles. It's two samples at the same time. It's a whole different procedure. But as I said, now Thailand is part of the Minamata Convention, which regulates emission limits for mercury. I think your customers are going to really start asking you, can you do mercury sampling for me? This is the best way to do this. We'll take a 30-minute break, 15? And then another hour? Okay. Take a break. I'll be around. If you want me to show you where that pump will fit, we can take a look at the console.
ก็เดี๋ยวพักเบรก
Everyone stayed awake. Excellent.
พักเบรก 15 นาทีนะคะ เดี๋ยวท็อปิกที่ 4 จะได้เริ่ม 2:30 จะได้เลิกเร็วค่ะ โอเคค่ะ เชิญค่ะ
5 minutes, you need to listen to me, and you can go home. So did anyone think of any questions on PS11 while they were drinking their coffee? No questions. Excellent. Okay. So now we're going to talk about mercury sampling. And again, this might be pretty new to most people in here. Okay? But we'll talk about Method 29 and the Ontario Hydro Method, which are the traditional isokinetic sampling methods for mercury. We'll look at a cost analysis between Method 29 and 30B and why this is so popular. We'll take a look at the 30B equipment, what you need to do this method. Review the sorbent trap configuration. These are very unique to Method 30B. Maybe you haven't seen this before. And finally, we'll talk about executing the method, QA, QC, on how you do this method. So you may be familiar with Method 29 for US.EPA, and it's a multi-metal sampling method. You're looking for any or all of these particular metals here in the stack gas from your impingers. And you can do a 7 impinger version of this same method to also look for mercury emissions coming from the stack. Okay? So the impinger chain incorporates acid and permanganate, some pretty bad chemicals that you don't want to be near or touch or anything. Transportation can be an issue. There's a lot of different things that make this method very difficult to perform. Has anyone done method 29 here, yeah? Okay. So you can imagine with method 5 how difficult it is with only 4 glass bottles. You have 7 or 8 on the back. It's heavy, the glass breaks. I mean, it's difficult to perform. It's accurate, but it's difficult. So this is a method 29 train. You've got your regular method 5 here, probe, nozzle, filter, and then it's everything in the back here with your acid and your permanganate in all your impinges that extracts the metals that you're looking for. You take it to the laboratory, they'll analyze your capture, okay? So you can imagine from probe to your exit right here, I mean, it could be from me to you away. It's huge, right? With a 7 or 8 foot probe and then a hot box and then impinges, and it's a very difficult setup. It's very big. Then if you look at Ontario Hydro, you've got 9 impinges that you're looking for. This is typically what's performed for looking for mercury as well. So now you've got even more glassware, more impinges, more weight. You need ice to keep the impinges cold. And when it's 35 degrees and really humid, the ice disappears very quickly, I imagine, and it's a constant battle to keep this train operational and moving. Okay. So a lot of years ago, the US EPA looked for an alternative, some way different to measure mercury coming from the stacks. So they did a study to all of the known values that they had, methods that they had, and then also they started experimenting with method 30B, okay, with the sorbent trap. You can see here Ontario Hydro method and the equivalent ASTM method and method 29 and 101A, which is the original mercury method. 2 to 4 hours, lots of glassware, lots of ice. Takes you a lot of time to recover the filter, get the impinger bottles, get them safe, break down the kit, all these different things. And you can see here, though, the advantage is you can get anywhere up to 10 different metals out of that one sample in method 29, or 6 or 7. It drops down to 1 or 2 here at 101A, and then finally 30B, you're only going to get 2 samples. But that's more than enough to, if we're specifically looking for mercury, okay? And then you can see the cost of performing this method as well. Here, you're looking at maybe 3 or 4 guys or girls going to the stack, setting up the test, lifting the equipment, all these kinds of things, where for mercury, theoretically 2 people's more than enough to perform this testing. Very, very simple. So what we're looking at here more likely is our gaseous phase mercury, okay? We're looking for mercury in the gas phase that's being emitted out from the stack as a gas. We're not looking for particulate-bound mercury at all with this method. And we're not looking for any other metals here either. It's only going to do our gaseous here and our elemental mercury as well. We can separate the types of gaseous mercuries that we capture. Okay? So you can see here the skill level required to do a method 29 or entire hydro is quite high. You have to have a lot of experience doing method 5. You need to know all the chemicals that go into the impinges, how to do the recovery correctly. There's a lot of expertise and knowledge that go into performing the isokinetic or wet chemistry methods of mercury. Whereas for the sorbent trap equivalent, it's quite low. It's very simple, very, very simple. Someone on their first day with a little of instruction can probably perform this method. Not too much experience required. And you'll see here at the bottom that NHG SEMS is pretty high. We can talk about how they correlate here in a little bit, like the gas met CMM in the back there and how that correlates to this. So again, you can see here the parameters that we're looking for, how this is working. So it's really a time average, okay? So we're going to sample our gases, our gas for a particular amount of time. We're going to look and see how much mercury we've collected, and we're going to work out our average concentration. We're not going to see spikes or dips in the mercury, just like we would not see spikes or dips with our method 5, all right? Our method 5 is going to tell us the average emission rate for the time that we were sampling based on our capture. We're looking here for total mercury and speciation, looking for the different types of gaseous mercury that we can collect on those filters, on those traps. And again, it's only in the vapor phase, no particulate bound mercury at all in this method, okay? So method 30B, as the US EPA states, is designed to measure the mass concentration of total vapor phase mercury, gaseous mercury, in flue gas as micrograms per dry standard meter, cubic meter. Known volumes of flue gases are extracted from the stacked or duct through paired in-stack sorbent traps. So we're using 2 traps, 2 samples, 2 gas meters, all combined in 1 unit. So we're doing, it's kind of like our paired method 5 sampling that we looked at. We're doing 2 at the same time to compare those values to see what information that we get. And it's collected on a sorbent media, which is typically activated carbon. So we're going to have beds of carbon that we're going to collect our mercury on and do a laboratory analysis after we capture. We come back from the field. So this is the schematic as it is shown in the regulation in the US, exactly, okay? So right here, we have our 2 sorbent traps that go in the front of the probe. And a sorbent trap is about 30 centimeters long and about 10 millimeters in width, okay? And it has either 2 or 3 beds of carbon, sections of carbon, separated by a small filter between each one, okay? Then at the back, the glassware comes down into a point, and the gas will go through the probe, through your sample line, and make its way to your console, your instrument, where you're going to be reading your operation. So again, the gas comes through. This is where we're capturing our mercury, right here, inside the stack. The probe is heated. The heated line is heated. We're keeping all of the moisture in the gas at 121 degrees Celsius. We don't want any condensation in the probe or the line until we get to our water knockout here. This can either be an electrified water knockout, like a Stirling cooler that cools down the gas using electric capacity and removes the moisture, or you can have a passive system like silica gel or whatever to pass the gas through to dry and clean it like you would in your Method 5 system. So both are optional, but we're looking at drying the gas and cleaning the gas. This is our aim, what we're trying to do. Then we're coming through to our pump, our dry gas meter, and just a rotometer. This is not an isokinetic method. We're going to sample at the same constant rate. So there's no need for a delta H or a delta P number. We just need a rotometer with a liter per minute value, and we know what we're sampling. Okay? And that's the same as you know with all gaseous sampling. It's constant rate. If you're looking for a particulate bound something, then you need to be isokinetic. So this is a picture here of our 30B system. So I'll show you a close-up picture here soon, but the traps are in the front here. Heated probe, heated junction box to connect our umbilical. This is all kept hot and heated till we get to our chiller where we remove the gas. Then we take a clean and dry sample to our console. And within this complete system, basically we have two independent systems, A side and B side, okay? So there's two traps, two lines, two sample lines, two knockouts, two gas meters, all combined in one system, okay? And then after we've done sampling, we're going to compare A and B to make sure they match, like a correlation, like we talked about before, okay? So this is a picture of a typical sorbent trap. So you can see it's a glass tube. The gas will come through here. We're going to collect our mercury sample on the first section. But we're also going to check this section for what's called breakthrough. Did any of the mercury move from here to here while we were sampling? And if it did, how much did it move? And if it was a lot, what's the reason why it moved? Because if you have high breakthrough, if you have high mercury moving, then there's something wrong with your sampling, okay? It's an indication that maybe we're not capturing the correct known value of mercury in our system, okay? Might be a sample. So in some sampling methods for 30B, you might have the lab pre-spike this section. So before you use the trap, the lab will put a known amount of mercury on your trap. Then you go and you use it in the field, and you come back, they analyze the trap, then they deduct the spike that they put on there to see how much mercury you captured. And the reason for this is, if you take your spiked trap to the field and come back, and the amount of mercury on the trap is less than when it left, we have a problem, okay? The mercury has disappeared during our sampling. And that's usually for one of two things. Maybe it's moisture. It got wet. And that spike was pushed back to our breakthrough section with moisture. And then the second reason is temperature. The temperature gets really hot, you can vaporize the mercury and it will disappear. You burn it off the trap, okay? So again, this is a QA, QC procedure to make sure that the testing that we're doing is accurate. Really, that's what we're doing here. So this is a picture at the beginning at the front of the probe. So you're going to install your traps that'll sit down inside the probe on A side and B side. And you connect them here with just a nut and a ferrule to keep them nice and tight, okay? They're going to stick out maybe about this much in the front, so the tube is in the flow of the gas itself, okay? And then this guy here, this is just your temperature, your thermocouple reading for that probe, okay? So typically, you're always going to have a heated probe to guarantee that we keep the moisture away from the traps, okay? In very rare instances, if you've got a really hot source, you might actually have to do the opposite and have an air-cooled probe. Because if it's too hot, you're going to burn off the mercury and you will not get a representative sample of the emission. Maybe you need to cool down the traps to make sure we capture all that mercury when we're operating. So QA, QC, how do we perform this method correctly? Just like your Method 5 system, a yearly gas meter calibration. We've got to make sure our gas meter is reading the correct volumes when we're using it. We're going to audit our thermocouples. We need to make sure we're reading our temperatures right. Because again, temperature is important to the capture of our mercury on our traps. If we get too hot, we're going to burn it off, and we're not going to have a good result. And then we're going to do just like we will with our isokinetic and pre- and post-leak check. We want to make sure that our system is airtight. We don't want ambient air getting in and biasing our results low, okay? So you would do your leak check almost like you do your Method 5. Take your thumb or a cap, put it on the end of the tube after you've installed, okay? The traps need to be in there, then do your pre-leak check, okay? So you put a cap over the glass, pull vacuum, no leak, perfect. Take it off, start. So if you do a leak check, then take the nuts off and put the glass in, you've changed the system. You took something off. So now your leak check is no longer valid. You've got to keep the system the same after you've done your leak check. No changes. If you change something, do it again to make sure it's airtight, okay? So it's paired sampling. We're going to take trap A and trap B, and we're going to make sure that capture on both sides is within 10% of each other. If A is here and B is way up here, something went wrong, okay? You can't have no mercury on one trap and enough mercury to kill an elephant on the other one. Something went wrong, right? Because they're right beside each other in the stack. They're right here. So were we not pulling gas through side A? Did we get a high vacuum on one side? Something must have gone wrong. Okay, so this is a QA, QC. We're going to check. Within 10%, good. All right, we got a pretty good, accurate test. The measured mercury concentration, less than or equal to 1 nanogram per meter cubed, is the relative deviation criteria, okay, with plus or minus. So it depends on how much mercury you're capturing to how much variation you can have between the traps. At high levels, 10% is fine. If you're sampling really, really low levels, then your window becomes different. It becomes closer. And it's actually based on a value, okay? So again, this is comparing A side, B side, making sure that they're good. And then we talked about this earlier, trap breakthrough, okay? So let me go back. If you have more than 5% of the mercury here than you captured here, your test has failed, okay? Ideally, this second section should be 0, okay? But if it's 1 or 2%, you're still okay. Good test. Anything above 5%, something again went wrong, okay? Do we have a temperature issue? Was it moisture? Things like this. Happens all the time, okay? Happens all the time. So the key advantages of doing this method versus method 29 or Ontario Hydro is cost. It's very cost effective. Very easy to do. Typically for a 30B correlation study, so again, 30B is the reference method. It is the standard. So if you're installing a gas mat CMM, you need to compare it to method 30B to make sure it is operating correctly, okay? So what you would typically do is do 12 complete paired runs of about 30 minutes each. So taking into account changing traps and doing some pre and post leak checks, you'll probably be looking at maybe 8 or 9 hours to do 12 runs, 24 traps total, okay? Then you can plot all 24 or sets of 12 on a graph, and you can discard the 3 outlying ones. So you're going to report 9 sets of traps or 18 traps completely, okay? You could get that done in a day, okay? 30 minutes a run, 15 minutes a change, you're looking at 45, a solid 9 or 10 hour workday, but you can complete that. Do you think you can do 12 method 29 runs in a day? No chance. No way. It would be impossible. It would take you, say, 2 a day at best, right? And you want to do 12 of them, you're looking at 6 days just to complete the method 29 training or sampling to compare to your mercury SEMS instrument. So it's hugely different, hugely different. So that's where the time comes in. Significantly shorter time, much more efficient, much less equipment. Accuracy, it's the reference method. It is the standard. According to the EPA, it's the most accurate method you can do for gaseous mercury. So you know, again, as long as you perform the method correctly, the same way you would tomorrow and the next day and the next day, you're going to get good results, okay? Accurate results. And finally, the ease of the method. Put 2 traps in, do a leak check, pull the plug off, stick it in the stack. No traversing, 1 point, constant rate, 2 liters a minute. Wait for 30 minutes, finished. Pull it out, post-leak check, next one. Simple, right? Real simple. Even I could do it. Easy. So that's a bit of benefit as well, okay? Really good benefit to this method. So let's go back real quick and look at a couple more things while I got you, okay? So there's a couple of different options with the system. One is the probe, okay? We can do stainless steel, heated. We can do Inconel, heated, if we have some challenging conditions with the gases in the stack, high SO2 or something like that. We want a real robust metal in there. We can do dual heaters, maybe not so important here in Thailand. But when we go to places like Chicago or Minnesota in the winter, and it's snowing outside, okay, and this much of the probe is in the stack, and it's 125 degrees, and this section's sitting out in the snow, and it's getting cold, okay? So what we can do is we can actually have one heater here, and it goes to about here, and a second heater in the back that will run independent. So now we can combat the ambient conditions outside, okay? So the back heater might run hotter than the stack heater because it's 0 degrees outside. Again, probably not a problem here in Thailand. I'm not sure when the last time it snowed in Thailand. Maybe never. So you probably won't have this challenge. But if you were to go overseas and do mercury testing, I want you guys to make sure you know that different ambient conditions can change your sampling philosophy, okay? I don't know, maybe one day you'll, I don't know. We got some guys in Iceland who I was there in October last year teaching them how to use the 502 and isokinetic sampling. And honestly, I'm not sure which is better. 38 degrees and humid in Thailand, or minus 20 and this much snow in Iceland. Horrible conditions. Horrible conditions. So cold. Dark all the time. But they get it done. They get it done. To the point, obviously, most of the time they're putting hot water in their cold box to keep the water from freezing. Here we have to add ice. They've got to do the opposite to keep the impingers working properly. So there's unique situations. Again, we can do, this is our Stirling cooler. It works. It's got nitrogen inside. It presses and it makes a little coil on the end freeze, makes it cold. Then we run the gas by it to make our sample cold and to drop out the water. The other option, as I said, is passive, silica gel or something like that to remove the moisture and the gases from the sample. And then finally, we have our 30B system, which is our digital system. It has a digital readouts for the gas meter and software that goes along with the system. Or we have a manual sampling system. 2 gas meters, you read the information as it ticks over, just like you would with your manual isokinetic system. So I don't know if anyone's read the poster on the back there, but right at the bottom it says method PS12A compliant, okay? So that's Performance Standard 12A. So there's Performance Standard 12A and Performance Standard 12B. Performance Standard 12A is a real-time SAMS mercury monitor, like the GasMet back there, okay? You install it, it reads the gas, it gives you real-time mercury numbers live. PS12B is the sorbent trap method, but for continuous sampling, okay? So it works a little bit different than 30B. Obviously, we put it in a big cabinet with air conditioning and all the environmental parameters to keep the instrument running in the heat. or inside the stack, things like that. But PS12B is also sampled proportionally instead of constant rate, not isokinetically, proportionally. So isokinetic is if the flow is here, we are here. And if the flow goes up, we match it. If the flow goes down, we match it again, okay? Constant rate sampling is regardless of what the flow is doing, we're always sampling at the same rate, okay? 2 liters a minute, whatever it is. Proportional sampling is the flow rate might be here, but we start sampling low down here. And if the flow rate increases, we also increase as well. But it does not match the flow. It's proportional to the flow, okay? So typically it's done around 1 or 2 liters a minute, right? Whereas the flow is going to be much faster than that. So if the flow goes up 5%, okay, so say the flow is 20 liters a minute, and it goes up 10% to 22 liters a minute, and we're sampling at 1 liter a minute, we will go up to 1.1 liters a minute, okay? We're going to go up the same percentage as that flow changes. That's for PS12B, okay? The traps are the same. You do a pre-leak check, you put your probe in, 1 point, you start sampling. Typically the traps will last about 7 days, okay? 7 days you'll run those same traps, sucking, okay? The only time you may not make 7 days, the maximum is 10. The EPA says no more than 10 days. You have to change the traps, okay? Places like cement facilities where they have the kiln on and off, usually 1 day a week, okay? They shut the kiln down for maintenance, things like that. They'll typically change the traps. So they may do 6 days. If you've got a high PM load, okay? So you start getting some really bad buildup here on the front, PM all over it, and your suction starts creeping up and up and up and up. Maybe you need to stop sampling, go and change the traps, clean out the system, start again, okay? So that's PS12B. I would say out of all the facilities in the US that must perform mercury SEMS, so 24 hours every day of the year, mercury sampling, about 80% use sorbent trap and about 20% use PM SEMS. And the reason for that is 2. Again, ease of the method. You do a leak check, you put the traps in the stack, you come back in 7 days. Unless you have a problem with moisture or vacuum or something, it'll keep running. And the other is cost. Significantly cheaper to run than a mercury SEMS. But you don't get the real-time numbers. Okay? You're going to get an average for that complete week. My average mercury concentration for the whole week was this number. Sometimes it might have been high, sometimes it might be low. We don't know. I can only give you an average. So that's the drawback from this method. Okay? So different customers will have different opinions, what they want to see, and the information that they want to access. But regardless if it's a PS12A or PS12B system, you have to check it with a Method 30B system. You're going to run them side by side at the same time. That if you're doing PS12B and 30B, you do traps, you take them both out, you change them, put 4 more traps in, go again, go again, go again. And then you're going to analyze both sets and make sure that they match. Or with the PS12A system, you're going to run it, you do your traps, you take them out, you'll collect the data from the mercury SEMs and compare them with that set of traps, and then do it again 12 times over, okay? There are other facilities, at least in the US regulation, that allows for periodic only 30B sampling. If you are considered a low emitter of mercury, your mercury emission level is low, and you can prove that in your 30B testing, for the first 3 years, you only have to test once a quarter, 4 times a year, okay? And if you do that for 3 years, so you've got 12 tests showing you're constantly low on mercury, then you can switch to once a year after that. Come in, do your test, I'm still low, great. Go to the next year, okay? So that's a difference that's allowable in the US. So it depends on the facility and what they need to do to be compliant with the regulation. So again, very different than isokinetic sampling. This method is used in the USA extensively. It's now the accepted method in China. India has just started trials on 30B with their national power company that sits in Delhi. And then Europe needs to be compliant with mercury by 2021 is their compliance date. So now a lot of facilities are looking at which technology that they want to use for reporting mercury. And again, a lot of people are asking questions about this because it's easy. It's easy, simple to run. Right? One guy for maybe an hour a week can keep the system running. A mercury SEMS probably needs 2 or 3 hours a day because you've got to put calibration gas to it every day, check that it's running right, all these different things. So there are advantages and disadvantages to both systems. But I think what's going to happen here and in most countries is most people are going to start with 30B, at least to get a mercury inventory level of, all right, let's figure out what's coming out first. In general, are our mercury levels high or low? You know, we might go to 100 industries in Thailand and figure out there's really not much mercury coming out. Okay, so then let's use 30B and we'll test it a couple of times a year. Hopefully not, but you might go and mercury's really high. Okay, now we need to do full-time monitoring to make sure that we're trying to bring those levels down. So, I know some of you guys have a long drive to get home, so I won't keep you much longer, but does anyone have any questions about 30B, the method, the equipment, anything like that? And I'm assuming this is pretty new to most of you here in the room. 30B is kind of new, but it's been going in the US since 2008 with a lot of success. And I would say 95, maybe even 97% of mercury sampling now is done by method 30B, and maybe 3 or 4% done by method 29 or Ontario Hydro, just because it's easy and it's simple. So, any questions? No questions. Everyone's ready to go 30B testing tomorrow. Let's go. Well, I appreciate everyone's attendance. Thanks for traveling in and listening to me for 4 or 5 hours in English too. But I want to reiterate that even when I leave Thailand on Friday, I'm here to help with any technical questions you might have. Liaise with NEDIS. They can get in touch with me at any time. Even if it's something very simple. We have a great staff. We have 4 technicians in our technical group that have been stack testing for 25 years, some of them. So they have a lot of knowledge and have a lot of expertise when it comes to real unique things, right? Challenges and sites where there's just unusual things happening. Feel free to reach out to me anytime and ask questions. We're here to help. And then hopefully maybe next year we'll be back and maybe do a full seminar or something on 30B. If we see that the government and everyone's pushing towards Mercury, we can come with some equipment and do some hands-on training and get out in the field with it. Again, you'll be surprised how easy it is. It's a nice change. So thank you, everybody. Appreciate your time. I'll be around for a couple of minutes, no doubt, to answer any questions. So thank you.
ขอบคุณมากครับผม การสัมมนาในวันนี้นะครับได้เดินทางมาถึงช่วงท้ายของงานแล้วนะครับผมดังนั้นจึงขอเรียนเชิญประธานในพิธีวันนี้นะครับคุณนวรัตน์มิตรจิตนะครับขึ้นมากล่าวปิดงานการสัมมนาในวันนี้ด้วยนะครับผมขอเรียนเชิญครับ
ครับในนามของบริษัท US.EPA Method นะครับขอขอบคุณพันธมิตรทางสิ่งแวดล้อม24บริษัททั้ง24บริษัทที่ให้เกียรติเข้าร่วมสัมมนานะครับแล้วก็ทางเราหวังว่าถ้าท่านนึกถึงการตรวจวัดที่เบาและง่ายสำหรับป่องขอให้นึกถึงEPA Instrument นะครับถ้านึกถึง EPA Instrument ก็ให้นึกถึง US.EPAนะครับเรายินดีให้บริการนะครับทั้งงานขายการเช่าแล้วก็เทิร์นเครื่องนะครับสุดท้ายนี้ต้องขอบคุณทางวิทยากรที่เป็นผู้บรรยายมาราธอนของเราก็คือมิกซูโพนะครับแล้วก็แขกผู้มีเกียรติที่เข้าร่วมสัมมนาทั้ง24บริษัทแล้วก็น้องๆทีมงานจากบริษัท US.EPA ทุกท่านครับขอบคุณครับ
ขอบคุณมากนะครับผมขอให้ทุกท่านเดินทางโดยสวัสดิภาพนะครับผมขอบคุณครับ